All right, perfect. Hi, Rodrigo. Welcome back. And anyone else who's joined us again, thank you for coming here, making the time from whatever time zone you're in. Welcome to our second webinar with SQM. The first one happened a couple of months ago, and over there, Rodrigo walked us through exactly what the deployment was, all the things that they have done, and he only gave us a little teaser about what exactly happens in the post processing end of things. So, Rodrigo, hi, how are you doing?
Hi there. Doing great, thanks.
Perfect. So, we're going to keep everything more or less the same. I'm going to share my screen really quick, and we can, just start off with you introducing yourself once more, just for any new listeners that we have. And I think you and go through like any previous context that was discussed in the webinar before, and then we can get down to the real stuff for this one. Is that okay?
Sure. Sounds good. You let me know when I can start.
Perfect. Let me just share my screen. Uh, just a second. Yeah. All right. Perfect. Okay, there we go. Let's just start from here. So, welcome back, everyone, and hello, Rodrigo. Let's start with the problem you had outlined before, and what exactly was happening in the leaching piles before the drones were introduced.
Sure. Let me start by saying hi to everyone. Well, my name is Rodrigo Toller. I'm the lead innovation and projects leading with technology here in SQM. So very quick sum up of what happened or what was our issue or our problem on the field was that on our operations, sometimes because of our scale, it was kind of tough to make sure that each sprinkle system was working the correct way. So you can say in the past, our team will take 2 weeks to go at least once on each pile to see if the irrigation was correct. And that was bringing a lot of issues on efficiency, on the concentration of the product. You can say we were losing product because of this lack of efficiencies.
Got it. And
So,
could you,
okay, so
sorry,
go ahead, Nita.
no, please. I
Oh,
was just going to ask you what exactly you mean by what exactly you mean by efficiencies and what these areas exactly look like.
yeah, I was going to go to that part. So amazing that you show in this image. So when we're talking about efficiency, let's say the perfect pile or the perfect irrigation will be that the entire pile is irrigated evenly. You can say that a good representation could be where it says humid area. That's, you can say, a perfect look of a leaching pile with a good irrigation. But as you can see in this image, we had different scenarios. You can have, we had used to have a lot of dry areas where probably the sprinkle system wasn't irrigating correctly, or we had
Mm-hmm.
flooded areas where probably the sprinkle system was tilted, or we had issues with the hoses that bring water to the
Yeah.
sprinkle system, and we created some, you can say, ponds that would affect our uh, final yield.
Yeah. Got it. And I see that. I understand what this image looks like. But my question is then, why didn't you just use, people to do this? Why did you need drones?
Great question. Like I said before, the size of our operation is huge. You gotta imagine that our operation is around 78 square kilometers, and we have
Yeah.
around 80 piles, and they are
Mm-hmm.
300 by 250 meters.
Oh.
So we basically needed an army to go around, and we don't have an army to go around. We have a limited amount
Yeah.
of resources. So
Mm-hmm.
a drone uh, would be the best option to do this. And after we found out that DJI was now coming out with the
Sorry,
DJI.
Rodrigo, you're cutting off. Could you repeat?
Yeah, can you hear me? Hello, hello. Hello, Nivita, can you hear me?
Yeah, am I audible now? Is it better?
Yes, I can hear you now.
Perfect. Sorry.
Uh,
What's a webinar without technical difficulties, right?
yes.
So let's go back to why you needed drones.
Okay, like I said before, our size is huge and we don't have the resources to go every day to a
Yeah.
pile and make sure that the pile was being irrigated the correct way. So after we
Mm-hmm.
noticed that DJI was going to put on into the market this dock stations, we said, hey, this could be a good way to monitor our entire operation. But we
Mm-hmm.
needed a platform to get the images, program the missions. So we said, okay, let's make a project that at least we can survey at least once a day all of our piles. So that's how we started with one of our areas called Pampa Blanca. I'm sorry, Pampa
Okay.
Hermosa.
Mm-hmm.
We said, okay, let's scan the entire area and pinpoint each pile and make missions to go and take pictures.
Got it. And just in terms of, you talked about this being a problem with time efficiency and cost efficiency. What was the
Yes.
change from, before drones to drones?
Oh, well, you'll see it on the
Yeah.
following images. But first of all, also I forgot to mention another big issue is safety. Since
Mm-hmm.
we're irrigating these piles, the the surface started to get soft. So the people that had to go and fix the sprinkle systems sometimes will cave in into this soft ground. So with this new technology, we were able to reduce the amount of times that someone had to go to the pile because they will only need to go to the pile when it was needed. In the past,
Yeah.
they will have to walk all over the pile if either the pile was okay or wasn't okay. So also that's another important point. Safety standards
Mm-hmm.
changed totally.
Got it. And just in terms of percentages, how much did you end up, how much safer did it become, and how much money did you end up saving?
Well, in terms of safety, we don't put it on money, but we put it on a scale of how much risk we avoided. And
Yeah.
if we want to put it on a number, we decreased the amount of time walking on, let's say,
Yeah.
dangerous terrain by 70%. So we
Oh,
only
wow.
had to go, yeah. So now we have to go to piles that are only with issues. We don't have to go
Got
to
it.
each pile that it could be, like I said before,
Mhm.
working okay and or with that had issues. Now we only go to the ones that really need to be taken care of.
Right. And of course, I'm sure there was some kind of like this transition that your team had to go to from, from man-made inspection to drone inspection. How much effort actually went into building this autonomy and getting reliable images?
Mhm. It took us a while to understand the technology, of course. Also, it was a little bit of a culture change.
Yeah.
You'll see in the following slides. But to be honest, it took us 2 to 3 weeks to understand how could the flow of flights can give us enough information to
Yeah.
create reports. So the
Yeah.
different areas that needed the images will
Yeah.
prepare tasks to fix or just make sure that the pilots were all right. But in 2 or 3 weeks, you can say we were already running with no issues.
Perfect. That's amazing. And when you see these images, you in the even in the previous webinar, you mentioned how the images go from flight base to your own data lake. Could you tell us a little bit about that?
Sure, sure, sure. That was one of the you can say parts of the process that kind of took it a little bit more to understand
Mm-hmm.
since we've never done this before.
Yeah.
Our company works with Microsoft tools, and one of them is
Mm-hmm.
Azure. So we had to make sure that all the images that they were captured and then put into the flight-based platform were sent automatically every X amount of time into our servers. So we had to, like you're seeing in this picture, have to create a flow of our information. So after we gather the images from the drone, we will process these images in models, computer vision models that will give us information of the pile, their status, how good we're doing the job on the pile, or where do we need to improve our hydration.
Got it. And uh, did you build these computer vision models internally? How did you exactly structure that end?
So the models were built from third party, but after we started getting images, our data science department had to a little bit
Mhm.
tune the model, so
Yeah.
the output was more close to what we were looking for. But you can
Yeah.
say it was a mixture between third parties and our department.
Makes sense. And what would you think was like the biggest challenge in ensuring this reliable data transfer?
Like I said, um, Flybase was more into lean into AWS,
Yeah.
Amazon servers, and since we had Microsoft, there was a little bit of challenge there to move images from one platform to another. But after that,
Mhm.
it was really, really easy to bring
Mhm.
our images and flow the entire process to our models. And
Yeah.
then, as you can see, use our data and analysis, which is Databricks. We started to
Yeah.
get reports probably a week or 2 weeks after we started getting images. So you can say it
Mhm.
was first a learning curve, how to connect stuff, but after that, it
Yeah.
was, you can say, fairly easy.
And did it work as flawlessly as you imagined it to? Has the computer vision model done its job correctly? Have you had any uh, problems when it comes to the detection and the calculation end of it?
Yeah, so nobody has done this before. So of course, it was at the beginning we started getting good results, but then we started getting input from the field, which is really good because they're the guys that have the experience, and they start to give us more details into, okay, you know what, this is considered good,
Yeah.
and this is considered bad. So we start to fine tuning our model with input of each image that we're getting every day. So
Yeah.
yeah, at the beginning it worked, but after let's say 2 months, the model was really, really tuned thanks to the input from the field.
Yeah, and just in terms of reliability, what like is it like 90% reliable? Like what's the faults detection rate over here, if any?
So we start to have weekly meetings with the field, and we had in a screen X amount of images, and we'll have like little voting sessions. So say, okay, do you agree or you don't
Mhm.
agree with the model? And we'll have, okay, a voting poll over there, and probably say sometimes we'll have 90% of the team that's in
Yeah.
charge of taking care of this agreed,
Hmm.
and that will help us to improve the model. But
Yeah.
I can say after 3 months, we had an acceptance rate of 98% of the model. So
Yeah.
yeah, actually, also we
So
learned that
that's
sometimes. I'm sorry.
no, no. Go on.
Oh, we also learned that during this learning curve that the time of the day also kind of changed a little bit of the image. So that was also something that we learned thanks to the input from the field. So yeah, yeah. So we now are in a 98% acceptance rate of the images.
Yeah. And I'm sure, like time, as you mentioned, time of the day. Although if there's some shadows that are falling, those obviously start hampering thermal imaging as
So
well. Did you say? Yeah.
So yeah, one of the you can say that 2% that we're missing is sometimes well, we live in the dry right here. We're working in the driest desert on the world. So
Yeah.
no rain, no clouds.
Hmm.
It's actually very good for our process. But sometimes we call something called altiplanic winter, and every couple of months when you might get a little bit of mist around the area, but it's
Hmm.
very strange. And that
Yeah.
change the thermal images. So we learned that with our environmental sensors and the weather sensors also, if we think
Yeah.
tomorrow is going to be a day that we might have mist around the area, we know that those images, the thermal images, will not be that reliable. So we'll rely more on the
Mhm.
RGB images. So that's kind of also that
Got it.
something that we learn on the learning curve.
Hmm.
Mhm.
Yeah. And how long have you had this process deployed for and running of production in production?
I will say June of last year. So it's going to be almost what, 8 months?
Okay, so you have one more season to get through.
Yeah,
Do
yeah,
you
yeah.
think do you think in the coming few months you would have to tweak your AI again?
Sure. Well, we need to have an entire year, so we can say, okay, we finally took the entire process of an entire year. So
Yeah.
probably when we get into fall, we're gonna see that that change
Hmm.
in the images, and we'll need to tweak a little bit too. Or we might
Got it.
have model for summer or model for winter. That's also something that we've been thinking of.
Okay, that sounds interesting. And just to talk
Mhm.
about the impact this has had, right? So how has this changed the way operations team prioritize, their day-to-day tasks from before to now?
I think if you go to the next slide, they can also show what we're using right now to do that. And there we go. So every morning, the team gets all the images from the piles, and the model gives two different sections: the top three or top 10, according what the user wants to see, the most humid piles, and the other piles that have more amount of ponds or little, like we saw in other images, little sections where there's a little water that's being accumulated. So they
Yeah.
will go to those top three, and they will
Hmm.
attack that and they will fix it.
Got it.
Every morning, the shift goes and checks this screen that you're showing right here.
Yeah, makes
So
sense.
they'll say, okay, yeah. So they will go and see this in this image. We see the pile number 647 has
Yeah.
57% over irrigation. So you should
Hmm.
go and check it over there.
Okay. So
Mhm.
basically, you first collect your images on Flightbase. From Flightbase, you send it to your S3. From there, it goes into your data lake. Over there, you use computer vision to analyze these images and check for, flooding, dry areas, humid areas, and all the other things you described previously. And it's able to take all of those into consideration and make these calculations we see over here and then prioritize the piles.
Yes, yes.
Uh,
So actually, the team on the field said, okay, if the pile is only 57% humid, that's for us a red, light. If it's 60,
yeah,
okay, that's yellow. Everything above
mhm,
60, it's acceptable. So they
yeah.
will prioritize their tasks on the field according to those percentages that they chose what to be.
Yeah. Could you remind me again how many flights you're doing per day?
So per day right now, we're doing five on that
Five
area.
flights.
And yes, five
Got
flights, and we're getting more flights as the mining team is giving new piles. So we'll need to increase our flights a day.
So, what do you think is going to happen when you go from five flights to 10, 20, eventually 30? You have like a lot more images coming in. Do you see any
Yes.
point where the system might break or things you might need to adapt to?
So we basically believe that the biggest challenge will be that since we're also trying to use the flights to do other stuff than only humidity, we want to do other
Yeah,
type of studies.
yeah,
It might get to a point that we might need to have two drones per area, not just one. So that
yeah,
could be probably the next challenge.
yeah. Got it. Makes sense. And just out of curiosity, this is a very complex pipeline. How do you monitor its health and keep making sure? Like, do you have like
Yes.
a system in place? Yeah, do tell us about that.
Yeah. So if image doesn't get into our servers, every 3 hours, there's a script that makes sure that the images are there. And if they're not there, we get notified and we can go and manually send the request to fly again. So we get
Yeah.
the image, but I would say we have a success rate of flights of 98%.
Hmm.
So,
Yeah.
but it happens sometimes that the drone didn't go out because, let's say, wind issues, because sometimes it gets windy, so the drone won't go out, and we get that notification. So we wait until the wind calms down, and then we'll fly and get the images. But
Got
yes,
it.
we got a system that tells us.
That makes sense. That makes sense. Perfect. Thank you for answering that. Let's move to the next slide because I have a question about something
Oh,
you spoke about in the beginning, which is you lose product, is what you said, right? And
yes,
I want to
yes.
understand how is a delayed monitoring or inspection mission going to help save or lose product?
Okay, so here's the gold, you can say, or the iodine, because we produce iodine.
Yeah.
So let me explain real quick this little graph that we have over here. So what you're seeing on the blue dots are the concentration of the leaching piles, all right? So
Mm-hmm.
and the red line that you see over there, it's the tendency of the concentration. So
Yeah.
the vertical green line over there is when we started applying the drone as part of
Mm-hmm.
our system and part of the
Got it.
tools that the team that's on the field uses
Yeah.
the information to make the
Mm-hmm.
best decisions. So after we
Yeah.
started using the drone, you can see the concentration peaked.
Mm. Yeah.
We start to see an improvement in concentration. So
Yeah.
that was the signal that gave us the green light to expand this to other parts of the mine, and
Yeah.
it proved us that the model that we were using to say, okay, which pile to go and check works,
Mm-hmm.
because we started to get better concentrations on the piles that were already going down. So,
Mm-hmm.
like I said before, every morning, 7 in the morning, the team meets up, sees the best
Yeah.
opportunities to go and fix stuff. They go and
Uh-huh.
fix it, and we get results, as you can see right here, that the concentration it's improved.
Yeah. I mean, your team seems to be like really together and on board on this right now. But you did mention that there was some friction and a lot of cultural change
Oh yeah,
right in the beginning.
yeah.
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 How long did it take for you to convince, your internal team to start functioning this way? How long did that cultural shift take to be in place?
So as soon as because we started with just one little pile to show them that we were going to get better results. That little pile
Yeah.
gave us a peak in on return of iodine. So after they
Yeah.
saw that, after there was what
Yeah.
3 or 4 weeks that the concentration
Mm-hmm.
started to rise. That was the
Yeah.
turning point that said, okay, guys, this is something that we need to use.
Mm-hmm.
And first thing that operators think is, okay, this technology is going to replace me. So we had to say, no, it's not going to replace you. It's going to make your job way more efficient. You won't need to go
Yeah.
to piles that are okay. We'll just send you
Mhm.
to the piles that need your attention. Instead of going to
Yeah.
10 piles a day, you might need to go only to 3 piles a day. And your impact is
Yeah.
going to be way, way bigger. So after they cracked that, they said, okay, we will
Mm-hmm.
join your quest, and as you can see, the results were really, really good.
Yeah. That makes sense. Makes sense. But uh, I'm curious. Of course, when you bring dogs and drones and flight planning into picture, it's a whole other set of personnel, or it's a whole other, different. It's a different area of expertise, so to speak. So, did you train existing personnel? How did that work? Did you get people? Did you get hire pilots and train them?
Yeah,
What was that
yeah.
process like?
We had to train pilots. We also had to go through the national agency that regulates the drones. We had to
Yeah.
train them under those
Yeah.
regulations. We also had to train the team that goes into the field to use the tools that we have available. And
Yeah.
our data analysts also had a little bit of training on computer vision, how to tune different models. So yeah,
Yeah.
each different area had to go through a little bit of training. So, but that took us.
Yeah.
The most challenging, of course, was the government area. It's a little bit more of a
Yeah.
paper, process.
Uh-huh.
But I can say in 2 or 3 months we were already running. You can say a
Yeah.
system that gave us already an idea of how this is going to be working.
Yeah, that makes sense. And I guess over here on this slide, we talk about the pillars of, if you, like the pillars that, build your whole case study, which you've already explained in the past. And over here, this
Mm-hmm.
summarizes your entire system. So at the end of it all, how did the supervisors and operators respond once decisions were based on dashboard outputs? Like you told me, they meet up at 7 a.m. and then according to criticality rates, they decide on which piles to go to, which piles to not, take into consideration. But is there one person, what's your hierarchical system, right? Like one person who makes all the decisions and then like a team that just disperses to the piles?
No, like a funny thing is nowadays the operators that go to the piles and fix them don't want to go out to the field without the report of each morning because now they learn that they learn that I want to go work because remember we're at 35 degrees Celsius. Nobody wants to be outside, so they
Yeah.
learn that when they have that report, they'll go and do the job where they are
Yeah.
needed, not to,
Uh-huh.
lose time walking on the heat.
Yeah.
So they're like, okay, Rodrigo, where's the report? We won't go with that report. So it's a team decision every morning. The supervisors and the operators meet up, they see the
Yeah.
rankings, and they said, okay, team A go here, team B go there, team C go
Mhm.
here. So
Yeah.
it got to a point that this kind of information it's
Mhm.
worked as a team,
Yeah.
and the system helps to take the best decision, and basically they follow what the system is
Mhm.
giving them as a recommendation. Like you
Yeah.
saw on the previous slide, it's been
Hmm.
working.
Yeah. Amazing. And then going back to this, we spoke about this briefly in the beginning. Flight-based and SQM has also been talking about this for a bit. What's happening over here?
Okay, so the field team was like, okay, Rodrigo, I like what you're showing me. I like the tool, but I think we can do more stuff. So they're starting to now request to do stuff with the drone. And one of the things that we
Yeah.
found out is like with the drone, we can find which sprinklers or irrigation system is not it's not working or is tilted or has some issues on it. So we
Yeah.
done some testing with you guys, and
Mhm.
we found out that we can detect if a sprinkler is not working. Like you can see here on the
Yeah.
image, one is on the floor, and
Yeah.
as a result of the sprinkler being on the floor, we're not irrigating, and we're over irrigating an area.
Yeah.
So not irrigating and over irrigating, it's as bad. They're both bad
Yeah.
scenarios. So yeah, next steps that we want to try now is how to detect these different events that happen with the same
Yeah.
drone. Mhm.
Got it. And any other areas where you think, apart from sprinklers, that you need to start automating? Because right now, I'm sure, I mean, the computer vision you've built does not look at sprinklers right now, right? Just to clarify.
No, 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 no. This was just a proof of concept. Yeah.
Right. So, and right now, the computer vision looks and sees, okay, there's like maybe this is like overly watered or this area is a little too dry, and then someone will go onto the field and have to check if something's wrong with the sprinkler, correct?
Hmm.
So, how would this
Yes.
solution, uh, what do you envision in terms of just time, efficiency, safety? What percentage of impact do you think this system will have in place?
Okay, so when we see something that is over irrigated or under irrigated, that's a result of. With this, we can uh, avoid that result. We can detect the issue before we get under irrigated or over irrigated area. So we're now going a step back. So if this works, we probably in the future will not have the issues of, you can see here, there's over irrigated areas because we detected
Yeah.
before we started having those issues. And I think the next slide also has a pretty good picture of, there we go.
Ah, yes.
That's, yeah, that's a decoupling of a irrigation line. So that will probably create a pond over there, and
Yeah.
and also since the line that feeds the sprinkle system, it's not irrigating,
Yeah.
we have two issues: over irrigation, where you see the decoupling, and under irrigation,
Mhm.
where the sprinkler is not irrigating. So with this, we're
Yeah.
gonna, you can say, not predict, but have the solution before the result.
Got it. Out of
Mhm.
curiosity, how many sprinklers are there for every pile that you have?
300. Depends on the
That's
size
a
of the
lot.
pile, but yeah, it could be from 300 to 500. It's a lot of sprinkles.
Yes, it's a lot of sprinklers and it's a lot of piles, so the number keeps multiplying.
Oh,
How are you
it's
currently
huge.
keeping track? Yeah, how are you currently keeping track of all of this?
Like I said, in the past, it was an issue. Nowadays, now we know where some issues are, but we want to improve the model and
Hmm.
detect this kind of issues before we got the results. Where, like I said before, over irrigation or under irrigation. So drones are key right now here. That's why
Yeah.
we already bought four other drones for the rest of the operation.
Yeah. And apart from the sprinkler system, which right now, I mean, you're working towards making it more autonomous, but right now it requires some manual effort. Apart from this, is there any other area or process that requires manual judgment?
Yeah, we also want to make sure if we can use the drone to inspect the drain canals of the
Mhm.
process, because all the piles go to canals and they drain into a big pool.
Yeah.
Sometimes these canals have issues,
Yeah.
and that's another thing that we want to try with the drones. Every day
Mhm.
the drone goes through the canal and see if there is an issue on a certain area. So yeah, that's
Yeah.
another thing that we want to try.
Mm-hmm. Do you have any specific like timelines, like this year we're going to accomplish this and the next year we want to accomplish, because the future keeps getting better. DJI keeps getting these new docks released,
Yes,
and
yes.
technology is continuously improving. So how do you
Oh
envision
yeah,
that playing?
yeah.
Yes.
Yeah, yeah. Actually, the thing is, other areas of the mine want to work with us now. For instance,
Oh,
the mining operation that has the
yeah.
big trucks and the big bulldozers are
Mhm.
now saying, "Hey, can you look our equipment with this?" And we say, "Yeah, you can." And now they want to join into our adventure. So, yeah, we have a very busy schedule for this year and for probably the 2027 year as well. We are trying to focus right now on the leaching process, and
Yeah.
probably for 2027 we want to mix this part with the other areas like mining,
Hmm.
security, environmental. So yeah,
Yeah.
we have our hands full.
Clearly sounds like it. And just as a hypothetical, really scary scenario, let's say this system pauses tomorrow, right? This pipeline and process is no longer in place. What do you think is the first thing that's going to break?
My phone, because all the phone calls I'm gonna get from the field operators saying, "Hey, I don't got the platform, so my phone is gonna break." But we actually trained in a scenario where the internet breaks down and everything's not working.
Yeah,
And since this is a very slow process,
yeah,
we use images from a week past the scenario, and still
uh,
we use that as our recommendation where to go. Like I said before, since
yeah,
this is very, imagine a pile takes a year to drain and everything, so it's very slow. So
yeah.
that's how we train to a scenario
Mhm.
that everything breaks and we still work. But yeah, it's a big impact right now.
I can imagine. And out of curiosity, do you have like non-dog drones, like just like remote control drone pilots on standby to gather images in
Yes,
case,
yes,
like,
we do have pilots that they got their own drones, and
yeah.
they use it for other stuff, but
Mm-hmm.
sometimes they use it to make sure. Let's say, since we don't have the sprinkle system that detects the sprinkle when it's down, they will go
Yeah.
manually and check that in specific piles, not in the entire system, but in specific areas they will go and fly lower and do some decision making with those images. But yeah, it's not that big.
Okay, so but is that still like manual decision
Yeah.
making, or is that connected to your data lake by any chance?
No, 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 no. It's manual. They'll just visual confirmation. If they see an issue, they'll probably radio the guy, and he will take
Mhm.
action and fix it. So the system still works. But yeah, so far it's still manual.
Got it. Well, it's still a better backup than, having taking five
Yeah,
days per
yeah,
person to go, and that makes sense.
yeah.
Well, thank you, Rodrigo. I think like I asked a lot of questions. Thank you for being so patient with me
Oh, no
regarding
problem.
that. And now it's basically time for our audience to ask us any questions. So I'll just repeat them and you can, answer them as you see. So we have someone asking us, has there been a false alert that caused unnecessary action after implementing this?
Has there been? Okay, yeah. At the beginning, we don't call it false alert, but we say not a correct reading. At the
Yeah.
beginning of the first model, we had sometimes that we will consider an area that was over irrigated, but in truth
Mm-hmm.
was just regularly irrigated. So we tuned that aspect of the image.
Yeah. Got it. Does that? I hope that answers your question. But just like as a little sidetrack, uh, did you ever have to send some people down the to the field and there was nothing wrong and they came back and it like really it threw things against you?
Not really, because when we had issues on regards of not issues but debate on which if either the image was right or not, the model, I'm sorry, the model was right or not, we will send the drone
Yeah.
again, but we will
Mm-hmm.
go even lower and stream that image live, and we will take a decision uh,
Mm-hmm.
um, using that image live from a lower
Yeah.
altitude, or zoom in into that area where we had doubt. But the drone was
Got it.
always the way to go into the field and detect if we had a disagreement on the model.
Mhm. Makes sense. Makes
Mhm.
sense. So, next question we have is, how do you balance inspection coverage versus battery cycles and the dock availability?
Yes, that's a pretty good question. Actually, what we did is we divided the piles on sectors,
Yeah.
and from the dock to the farthest section, it's around 3 kilometers.
Uh-huh.
So we made blocks, and so
Mhm.
far it's been working great. And also the dog takes what 20 minutes, 25 minutes to charge all the way up to 90%. So
Yeah.
we did our scheduling,
Mm-hmm.
taking that on into consideration.
Yeah. And if you run into any issues where maybe one dock, because of maybe hardware or whatever, becomes unavailable, then do you have to like go through do you have backups or do you have to go do the whole organization again?
If a dog it's out of service, if we have backups for DA dogs,
Yeah, a
we
backup or what? Yeah, how do you compensate for that one dog being out of service for now?
well we have dogs available. If one is out of service, we just either change the drone or change the dog. That's what
Okay,
we. It has never happened, but that's the plan. We have one
got
on always on shelf to be replaced if needed.
yeah, got it. Makes sense. You mentioned that you are flying 5 missions, right? So we have a question asking who decides how many missions run each day? Why is it only five?
It's only five because this was our proof of concept area,
Yeah,
and we actually decided to only do it because we actually at the beginning flew like 3 or 4 times a day per pile. But then we
yeah,
noticed the sun will affect how the irrigation looked on the images. So we got to a point that we agreed, okay, so every day we're going to fly only once a day at this time of the day, and that's going to be the scale to compare Tuesday with Wednesday. Because if we compare Tuesday at
Mhm.
3 in the morning, 3 in the afternoon with Wednesday at 5 in the afternoon, of course it's going to be
Yeah,
different because the evaporation rate is going to be different. So that's why we did it
yeah.
only once. It was like the frequency was, like I said, 3 to 5 times per pile, but then we
Hmm.
noticed that difference. So, okay, let's all, do it once a day at this time of the day.
And do you see that number changing at any point? Like, is it always just going to be once a day?
It
Throughout?
could the good thing is we do it once a day. It enable us to use the drone for other stuff. Let's say
Mm,
sprinkle
yeah.
the drain system, because if we do it
Mhm.
more frequently, then we lose that you can say opportunity on the other missions that we want to try.
Got it. Perfect. Let's jump to the next one, which is where does the AI processing actually run? On-prem, in the cloud, or hybrid?
Okay. Uh, Today we run everything on the cloud. but we are we're thinking of doing some proof of concept on edge prem and also hybrid, because everything that we're running right now, it's through Starlink, because we're located in a very remote area. So fiber is kind of hard to get here or very expensive. So since if we're thinking to do computer vision with videos,
Yeah.
on-prem is going to be a necessity because of the data caps that Starlink's antennas have.
Okay, and would this like I think going from cloud to on-prem would change your process by
Yeah,
quite a bit. Right now you're
yeah,
going from flight base to, your S3, and
yeah.
so how do you see it adapting to that and what that's going to look like?
uh, it will only depend if the results that we get from the other models that we want to try are successful. I'm sorry. If they
Yeah.
are, we'll have to rethink everything and probably end up with a hybrid model that all the
Yeah.
images are processed on the prem, but the decision making is on the cloud. So yeah,
Mm-hmm.
that's how so far we've been discussing. But probably on the passing the different tests, we'll take the final decision. But it looks hybrid.
Got it. Got it. And I think we have one more question, which is why percentage-based classification instead of anomaly detection?
Uh, Good question. We had that conversation with the team, and they wanted a number more than the amount of anomalies. So we translate the amount of anomalies or surface area that wasn't being correctly irrigated,
Mm.
and we put that number into the platform. It was
Yeah,
mostly a request from the operation team that wanted a number more than the amount of anomalies.
yeah, got it. And okay, I think we just have like a couple more questions to go, and we have 10 minutes for this webinar, so I think we
Mhm.
should wrap up in time. What operational metrics improved more than you expected, once you started this new process?
Like I show in the slide, concentration was one of the ones that we were like, oh, it was pretty good. And
Yeah.
also the amount of hours that operators were on top of piles, that decreased a lot. So we were very
Yeah.
happy with that, because now they were just going, like I said before, into paths that really needed to be worked on. And
Mm.
the
Yeah.
operators not only take care of the piles on the top part. They also take care, like I said before, the draining streams. They also got to go and check if they were okay. So that gave them more time to do other stuff that were very, you can say, limited before. They had a limited time to do it.
Yeah, makes sense. And I'm sure like morale between personnel also changed because you told me how there's like really high temperatures out there and you don't
Yes,
want to actually have to deal with that. So I guess that was better for the team overall, yeah.
yeah, of
And
course
talking
it was.
about and talking about environmental factors, are there any environmental factors that affect flight reliability?
Yeah, like I said before, here it never rains. It's very strange, but we do sometimes. We're very close to the Andes, so we
Yeah.
sometimes have strong winds above
Mm-hmm.
12 meters per second.
Oh, well,
So
yeah.
the drone will, he won't fly. It will tell you, hey, I cannot go out because the wind's too strong.
Mm,
Um,
yeah.
Now and then we have sandstorms that also affect
Mm-hmm.
the images, of course. And basically, those are the environmental factors that sometimes affect our missions.
Uh, Talking just really quickly, how do sandstorms affect bleaching piles themselves?
Not that much. The evaporation rate increases a little bit, but what really affect on terms of environmental, it's a very, 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 very dry day. You want it to be
Hmm.
an okay day, because if it's too
Yeah.
warm, then everything that you irrigate on top of the pile, it evaporates. We have that into factor though. I mean,
Yeah.
it's in the equation, but yeah, that's it's very, very little what can affect the pile
Yeah.
environmentally wise. But yeah, he kind of
It,
steals our water.
okay. That makes sense. And like, is there like a specific way that you monitor weather with, and how does that fit into your day-to-day operations?
How do we worry? What? I'm sorry.
Is there a specific way that you monitor weather itself? Like
Oh, the
you take
weather.
that into consideration. Yeah.
Yeah, yeah. We have weather stations. Also, the flight base platform has also a little weather station that tells you if it's okay or not to go. So if we see
Yeah.
that tomorrow is going to be a day that we might have wind, we say,
Yeah.
hey, we might not have images tomorrow, but
Yeah.
that's basically it. But
And
let's say, yep.
mm-hmm. Go on, please go on.
No, probably from
Mm.
the 365 days of the year, we don't fly 5 or 3 days of the year. That's how low the
Yeah.
the the rate is.
Yeah, pretty low number. Uh, and as a hypothetical question, how many consecutive, like you told me how the irrigation process is very slow. If you miss like a day of images, it's in the grand scheme of things, it's not going to have a really high impact, right? But
Mhm.
how many consecutive days would you have to miss for it to have an impact? Out of curiosity.
Good question. I think they will start freaking out after the fourth or fifth day.
Okay,
Yeah.
got it.
But probably like I said before, since we already have the data where the pilots that have been giving us issues, we'll probably send guys
Yeah,
with drones, the little drones, and fly over them and
yeah.
gather that data. But yeah,
Hmm.
after not having the platform after 5 days, it's gonna probably affect us. So yeah.
Yeah. Uh, well, perfect. I think like we have run through all the questions the audience had and all the questions I had. Thank you very much and being so patient and explaining everything. It's always a pleasure to have you here. I'm sure you bring a lot of knowledge to the system for anyone who's into, mining or just wants to understand the different unique ways to solve issues. Just are endless, right? And you sharing this and bringing it to the table adds a lot of value to us and a lot of people. So thank you very much.
Yeah, always happy
Uh,
to show what we're doing and the power of drones and platforms that help the drones to gather the data for you.
yeah, and maybe at the end of the year, you have some more crazy things to show us with your
Oh,
more AI
for sure,
capabilities, and
for
we can
sure.
have you here back. All
For
right,
sure. We're
perfect.
gonna we're gonna have a lot of stuff. All right.
Perfect. Thank you so much, Rodrigo. It was great talking to you today, and thank you everyone else that joined us. If you have this video, will be available on our platform later for you to access. And if you have any more questions, feel free to shoot us an email. All right.
Thanks for
Have a
everybody,
good.
and see you later. Bye bye.
Bye.